I'm going to show you another example of how we can use kernel density to show clusters of events or populations even. Again, if the sort of graded color map isn't quite appropriate or doesn't convey the right kinds of information. I'm going to show you a couple of things. So what I already have here is a shapefile of census tracts in the Denver-Aurora urban area. And you already know how to do that using the sort of shortcut / cookie cutter method. One of the things I'll do then is bring in Colorado Public Schools. This is a shapefile of all schools in Colorado. And again, if I zoom out, you see all there's the public schools in Colorado. But obviously I only want the ones inside of my shapefile here. And where did I get that data? I got the data on public schools from the National Center for Education Statistics. They have a system by which you can download information on schools. And so if I actually open up the attribute table, you'll see the kinds of data they have. The address, the coordinates, further over the name, and then we get some actual data. Total number of students in that public school, American, Indian, Asian, Latino, Black, White. And then this is the number of those total students that are on eligible for free lunches, the number of the total students eligible for reduced lunches, and then the total of those. So this is out of the 1,899 students in this particular school, 1,736 are eligible for either free or reduced lunch. So that gives us a sense of the sort of class profile of the student body that school is hosting. And then of course there's the pupil to teacher ratio. But let's say we wanted to sort of do a cluster analysis, a hotspot analysis, more formally a kernel density analysis of public schools, and we want to weight them by the number of students they have that are receiving free or reduced lunch as a measure of sort of a vulnerable population. So what we'd want to do is first of all just get down to the public schools that are in the Denver-Aurora urban area, and I don't already have that. So what I'll do is just use the select by location. I want Colorado Public Schools that are inside my Denver-Aurora shapefile. Centroid is fine. There we go. I've highlighted schools. I'm going to pull them out of schools. Export that data. Go ahead and save it. Call it Denor Schools. 659 of them, and I can get rid of the old one. Okay. Now all I can do is do the kernel density analysis. And again, if you don't see their toolbox, you can click on it here and pin it, and it'll show up there. But we can pull that out a little bit, and we're going to go to Spatial Analyst Tools. It'll look something like this. Go to Density, Kernel Density. Okay. So the point feature is the schools again. And then if we want to weight the population again, we wouldn't necessarily need to do this if these were just unique events with no particular reason to weight them. But here we can weight them by the total number of students receiving free or reduced lunch. And then we would make sure we're navigating to where we want to save it. So we'll call this DA Kern. Again, I'm going to just use the default settings here. Now notice, in contrast to the snow data, this one actually has a e to the -02. So if you ever change this, don't just highlight and change, because you want to maintain this kind of e to the -2nd degree or whatever. But we're just going to do the default for right now. And so we're running the kernel density. And again, I'll worry about switching stuff later. I just want to show this initial output. So again, that's how it changes all of those dots. It weights them by the number of kids receiving free or reduced lunch, and then of course assesses it in relation to densities and things like that. One of the things we can do, of course, is increase the tolerance just a little bit, just to see how that changes things. So, same process. Input is the schools, the weight, area reduced. Navigate to where we want to save. I'll just call it DA Kern 2 for Denver Aurora Kernel 2. And then instead of 1.85, let's do 2.45. Hit OK. And we'll see how this one turned out. Let me turn the top color off. You can see how this newer one compares to the older one. Okay. As you increase the distance by which it looks for similar type schools, you get a sort of a more aggressive shading of the map. So let's get rid of that original one and go with this more aggressive one. You can double click, go to symbology. If you want to stick with the single color ramp, that's fine. But I usually stick to 7. And then again, I kind of like the actually we want to reverse that one, so let's find the find where that is at. There it is, higher meaning red, and then we can also smooth it out. Again, you just go to this display and then bilinear interpolation, and let's transparency set it at 35. Again, turn that top blue one to null, and then we can get rid of the dots. Okay. And we can zoom in just a little bit here. And the other thing one could do is, if you go to the add data bit, if you do the drop down, you can add a base map, and that gives you some sort of established images. Let's actually do imagery. This might take just a second or two. Actually provides satellite imagery. Again, I have the census tract still outlined, so you can kind of see where those are at, and we can add transportation in. So we can see concentrations of children in schools, clusters of schools with high numbers of children that are receiving free or reduced lunch. Here's the Mount Bella neighborhood. Here's over here in Aurora near the Colfax Avenue and so on. Over here in sort of West Denver, where it starts to meet Lakewood and Littleton and so on. So there's where we see sort of populations or concentrations or clusters of what we might consider to be vulnerable populations.